Hello, I'm Barry Verspagen, mechanical technologist with the School of Engineering, and today we're going to do a sand casting demonstration. So this is the furnace that we're going to be using. I've got it all set up. It's warming up right now. I've got it set for 750 degrees Celsius. We're going to be melting 6061 aluminum. It has a melting temperature of around 660, so 750 is more than enough. It just helps speed it up. It usually takes about an hour and a half for it to melt, but it also depends on how much aluminum you have in there. The crucible that's inside the furnace is this size. It's made out of clay. It can withstand temperatures around 1250 degrees Celsius. I don't think I'd want to go any higher than that. It is quite heavy, but prior to putting the crucible inside the furnace, I like to make sure that there's no cracks, there's no damage, just an overall inspection of the quality of the crucible. Because the last thing I want is to be picking the crucible up out of the furnace and having it crack on me. Very dangerous. Molten aluminum splattering all over the place. We have different sizes of crucibles as well. Here's a smaller one for smaller runs. And all the tools necessary for conducting the process. Another safety reminder when you're in this area, please don't assume that anything is cool to the touch. Use cautionary discretion, please. We're going to show you inside the furnace. As you can see, it's warming up and the aluminum hasn't melted yet. The molding boxes that we have, they come in various sizes. We're going to use a smaller one because we're just doing a demonstration of a small casting. Just to let you know that there's two halves. This is the cope and the bottom is the drag. They have locating pins so that you can reinsert them into the exact location all the time. Inside the molding box, you'll notice that the walls aren't perfectly flat. It actually concaved. The purpose of that is we're going to be packing this full of sand, and you will have to move the box around, and when you pick it up, you don't want the sand to fall completely out. This particular one, you can actually see the ridges and the grooves. Okay. So this is the sand that we're going to be using. It's called Petrobronze sand. It's very fine sand mixed with oil. It's recycled. It can be used several times over and over, but it does tend to lose its quality. One way of checking to see how good it is, I like to pack the sand into a ball, and then I try and crack it in half. And that shows the adhesiveness of the sand and how good a quality it is. If you look at the color, it's a dark brown now. In front of you is a bag of brand new sand, which is roughly about $140. When the sand is expired and it's no longer good quality, I just replenish it with a new bag. These are the molds that we're going to be casting. We printed them on the 3D printer in the AML lab. As you can see, it's got some locating pins for the two halves to line up perfectly together. These are a little old, they are a little warped, and you'll see that in the quality of the casting. Because of the warped and the gap in between, you're going to get aluminum coming out the seam. That's called parting line flash. It's not really desired because it's an extra step in manufacturing to remove it. So today, we're going to be doing a couple chest pieces, and we're going to be doing Aluminum Man. Okay. So now I'm just going to move the sand gently into the corners, make sure it's nice and even. I'm going to get a bit more sand. So at this point, just going to move it over, flatten it out a bit. It is a bit of a messy job. Don't worry, we'll clean it all up later on. At this point, I'm just going to press down on the sand. As you can see, it's being compacted down. This is what's called a rammer. It's got two ends. We got a flat end, and then we have an angled side. Angled side is to get into the corners. What you want to do is you just want to use the palm of your hand and the rammer and just press down on it. You don't want to be too vigorous with your actions. Just press it down. This way the sand will slowly creep around your mold and it won't shift it around. Now that I've got the sides and the corners packed down, I will use the flat end of the rammer and I'm going to pack it down even further. Now you don't have to go too hard on it, but you do want it nice and solid because this is a foundation for your second half, which you will be compacting on. Okay, as you can see, it's compacted down quite a bit from what it was before. It is fairly solid. At this point, we need to scratch up the surface. If we don't scratch this up, the second layer of sand that we're going to put on here won't bond to it. So, at this point, we're not going to use a sieve. We're just going to fill the box up with all the sand. We actually want the sand to be overflowing because we're going to use this flat surface and the straight edge, and we're just going to shave it all off so we have a nice flat base. All right. Now, at this point, you want it overflowing because when you go to compact it down, you don't want to compact it down lower than the flat edge here. Otherwise, you're going to have to repeat the process again. As you can see, the sand is sticking to the rammer. I'll just put a bit of parting powder on it. Starting off in the middle and work my way around the edge. And now we're going to shave off the excess sand. There we go. Now what we want to do is we want to lift the box up a bit, remove the sand. As you can see, we have our molds in place. Those ridges inside the box are keeping the sand intact. And we're just going to clean off the excess sand off the table. Okay. All right, so we're going to start with the second half, the cope. We're going to place it on top. As you can see, we have enough room to insert our sprues on either side. And we're going to repeat the whole process all over again.
We've now completed both the cope and drag, filling them and compacting them with sand. We want to make sure that when we are filling the cope, we don't compact the sand too much because it could cause the sand between the cope and drag to bind, which would affect our mold. We are now going to insert the sprue into each end of the mold to create a riser on each end. One riser is to allow the aluminum to be poured into the mold, while the other allows air to escape the mold. It is important to remember where we place the molds relative to the mold box and to place our risers appropriately so they aren't touching but are still close. The depth to which we insert the sprue is important, and we have marked the appropriate depth on the side of the sprue. The risers go through the cope and reach just into the drag. Once we've determined the appropriate location for our risers, our next step is to slowly push the sprues into the mold. We're going to use a flat trowel and push down on top of the sprue, ensuring that it goes in straight and to the appropriate depth. You'll notice that as the sprue enters, some sand on the top is displaced. We can simply pack that down with the flat trowel. Here, Barry is checking the depth of the sprue and adjusting it to make sure we hit the line on the side. You will have noticed that the sprue has a slight taper to it. This is what caused the sand on top to displace when we were inserting the sprue, but it is there to allow the sprue to be removed smoothly and prevent any sand from falling back into our hole. To remove the sprue, Barry is going to tap on the sides and then twist it to break it free. Once the sprue has broken free, Barry is able to lift it out with a slight twist, giving us clean edges on the riser. The sprue is now filled with sand, which can be deposited back in the sand well. The process is then repeated on the opposite side of the mold to create the second riser. Once both risers are completed, any imperfections on the top of the mold can be addressed. If some sand has broken loose around the edges of the riser, we can pack it down with our fingers to ensure that it doesn't get dragged in. We can see that some of the sand from the cope has stuck to the drag when we separate the two mold halves. This isn't of huge concern and at this point will not be addressed, as it still fits back with the other side. We are now ready to prepare the runners within the mold, starting with the riser where we will pour the aluminum. The runners are cut into the drag. Here we can see Barry preparing the reservoir under each of the risers. There is some freedom in the path the runner takes from one riser to the other. It's important to choose the correct surface for where the runner will meet the mold. This surface should be selected as being the easiest to remachine once the part is cast. For the molds that we're using today, the base would be the ideal place for the mold and runner to meet. Due to spatial constraints within this mold box, for this demonstration, our runner will run straight through the three parts from riser to riser. Here we see Barry using a scraper to create the runner. He's careful not to disturb the molds, but removes a clear path between all the molds and the risers. He removes the loose sand from the runner, and if the surface breaks, uses his fingers to recompact the sand. We are now ready to remove the molds from the sand. To do this, Barry is going to insert screws into each mold and gently tap on the screws, allowing the vibrations to loosen the mold from the sand. He will repeat this process for all 3 of the molds we used. Here we can see the details of the imprint left by the molds, including the lines from the 3D printer. A scraper is used to finish the runners, and then fingers to compact any loose sand. A billows blows away the remaining sand, and this half of the mold is now complete. We repeat this process with the second half. With both halves now complete, Barry uses the billows to blow off any remaining loose sand, and the mold is now ready for assembly and then the pour.
So we're almost ready to pour. As you can see, I've got my PPE on. I'm just going to move the box over here onto our cart. The cart is nice. It contains all the sand, and if we do have any spillage of molten aluminum, the cart will contain it all. Now we're going to check the furnace and see how the aluminum's doing. As you can see, it's liquid, it's in a melted state, and if you look at the top layer, it's kind of grayish in color. That's all the impurities rising to the top. We're just going to take the ladle, you see that? And we're just going to scrape all the impurities off. Equipment, and I'm going to now remove the crucible from the furnace. Okay. Put your end down a bit. Okay. As you can see, there's smoke coming off. That's just the oil being burnt. We filled it in through here, it went through the cavity, and you can see it come up and then retract just a little bit to backfill into the mold. We're going to let this sit for about 5 minutes, let it fully solidify, and then we'll break it open. Okay? So now we're going to break it apart. It's still extremely hot. Wear your gloves. Okay, we're going to break the sand apart. As you can see, the black area, that's where all the oil's been burnt off. Okay. And there you have it. As you can see, we got the parting line flash, not desired, we don't want that. All this is going to be cut off with the saw. Like I said before, it would have been nicer if we had it in the bottom, because we'll just grind it off flat and you wouldn't have any of that. So after I cut off the runner and the gates and the sprues, this is the finished product. As you can see, we got maybe a bit of air trapped in here. That's called porosity. I ground off all the parting line flash that was around here. This one is excessive. I just quickly went at it, but there's still more to be done on it. The bottom, again. And then Aluminum Man, there was quite a bit around the shoulders